Looking back at what they call Einstein's biggest blunder, even Einstein made mistakes sometimes, and this was a big one. Einstein thought he could keep the universe steady by adding the cosmological constant to his equations. But then along comes Hubble, showing that the universe is expanding. It's like when you're playing a game and make a move that seems smart at first, but then you realize it's wrong. That's what happened with Einstein and his constant. In 1915, Albert Einstein published a paper called Cosmological Considerations in the General Theory of Relativity. In this paper, he used his theory of general relativity to explain how matter and energy cause space-time to curve, which is what we experience as gravity. He introduced this to balance certain calculations and further understand the universe's structure. During Einstein's time, he and astronomers believed the universe had a fixed size, and the space between galaxies remained constant. This created a problem because, according to the laws of physics, the Milky Way should collapse due to its mass. However, it didn't collapse, maintaining its structure. To solve this, Einstein proposed adding an extra factor to his equations. Without this addition, the universe would be unstable, shrinking when it shouldn't be. To make sense of the idea of a static universe, Einstein added something he called the cosmological constant, represented by the Greek letter lambda. This was like a special ingredient in his equations, helping to balance things out and keep the universe stable, even though it seemed like it should be collapsing. Think of it as a sort of fudge factor that Einstein introduced to make his theory match what was observed in the universe. In a letter to the Dutch astronomer Willem de Sitter, Albert Einstein shared his worry, saying, "I wondered if the idea of relativity could be taken all the way, or if it would lead to problems." He encountered big obstacles when trying to create a model of the universe that stayed the same over time. The main problem was that he wanted his model to follow two important rules: the principle of relativity, which says all viewpoints are equal, and what he called Mach's principle. This principle says that an object's resistance to changing its motion depends on all the other masses in the universe. In his important paper on cosmology in 1917, Einstein proposed that general relativity could describe a universe that stays the same over time. But he had to make two key assumptions. First, he said the universe had to be shaped like a closed sphere, with no clear beginning or end. Second, to make his theory consistent, he had to add a new term to his equations, called the cosmological constant. Some people didn't like this addition, thinking it seemed like a last-minute fix that messed up the equation's symmetry. But Einstein himself had considered adding something like it earlier. In the end, the cosmological constant turned out to be important because it allowed for a universe model that fit with Einstein's ideas about how inertia works in his theory of relativity. One interesting thing about Einstein's cosmological considerations paper is that he didn't investigate whether his idea of a steady universe was truly stable. He connected the universe's size directly to the density of matter inside it. But what if, over time, the matter's density changed? It turns out that Einstein's universe could become unstable because of these density fluctuations. Surprisingly, Einstein didn't seem to notice this flaw in his model universe. Just a few months after Einstein's Cosmological Considerations paper, Dutch astronomer Willem de Sitter made an interesting finding. He realized that adding the cosmological constant to the equations created a fascinating possibility: a universe with no material at all. In his paper, de Sitter described a four-dimensional universe where space-time was closed and expanding steadily at a constant rate, but there was absolutely nothing in it. Einstein wasn't too happy with de Sitter's model because it didn't fit well with his idea of Mach's principle. This led to a long debate between the two scientists. From what we know, there isn't solid evidence in Einstein's writings to suggest he completely agreed with de Sitter's solution as a true picture of the universe. In 1922, a young Russian physicist named Alexander Friedmann showed that in Einstein's theory of relativity, If you imagine the whole universe is uniformly filled with some kind of energy, like matter, radiation, or the energy linked to the cosmological constant, it can't stay still. It has to either get bigger or smaller, regardless of whether there's a cosmological constant or not. He changed these equations a bit and came up with two equations that linked how the universe changes with things like how much matter there is and the cosmological constant. Einstein wasn't quick to accept Friedmann's ideas at first. He thought there might be a mistake in the math of the Russian physicist's work. Einstein criticized Friedmann's model at first, but later he took back his criticism. However, a draft of his retraction that wasn't published showed that he still had some doubts about whether Friedmann's model was realistic. In 1927, the Belgian physicist Georges Lemaître used Einstein's equations as a base to develop equations for how the universe changes in size. He built upon Friedmann's work by considering the distances between galaxies that Edwin Hubble had been measuring since 1923. Lemaître also took into account observations made by Vesto Slipher as early as 1911, which showed that galaxies were moving away from us. From his analysis, Lemaître concluded that the universe was expanding. He not only published a paper on this, but also directly communicated with Einstein about his discoveries. Einstein didn't respond well to Lemaître's work. In Lemaître's recollection, Einstein disliked the idea of the expanding universe and even called it abominable. The big change happened in 1929 when the American astronomer Edwin Hubble showed evidence of a clear link between how fast spiral nebulae were moving away from us and how far they were. This discovery convinced a lot of scientists that the universe was expanding on a huge scale. As a result, many different models of the cosmos that changed over time and followed the rules of relativity started popping up. Einstein quickly changed his mind about his old idea of a static universe. In the early 1930s, he proposed two different models for a universe that was expanding. One had a curved shape, while the other was flat. In both models, he didn't use the cosmological constant anymore. He thought it wasn't necessary and caused issues in stable models. Einstein believed that relativity could explain the expanding universe without needing the cosmological constant. In 1931, Georges Lemaître had a brilliant idea. He thought about how, if the universe is getting bigger now, it must have been much smaller and hotter in the past. So, he suggested that our universe might have started as a tiny, super hot thing. This idea, later called the Big Bang model, didn't have many supporters at first. But in the 1960s, scientists found evidence that supported it. One crucial discovery was the cosmic microwave background, a faint signal from the early universe. Today, scientists still study it a lot to learn more about the cosmos. Thank you for watching, and until we meet among the stars again, keep dreaming big and exploring the infinite.